Hello all, welcome back to our C programming course. Previously we installed our compilers, we installed MSVC, GCC and CLang. So today we are going to have an overview of the example we wrote in our previous example. Without further ado, let's get started. First thing first you have to understand is the file extension. The file extension is not really important to the compiler, okay? The compiler don't really care about your file extension. It don't really matter if you write your file extension as a .cj file or as a .jargon file. It don't really matter. But one thing you can do is you come under tools and options. You can easily map a file extension by telling the compiler that when you see a .cj file, I want you to treat it like a C file. So file extension to a compiler don't really matter. A file extension is usually helpful to us programmer. When we see a file with the .c extension, we can easily recognize that this is a C source code, and it is also useful to the tools we use during programming. Our IDE can easily notice that this is a .c file. It can format your source code using the C formatting tools it have to build in. Without the .c extension, it would not be able to know if this is a C file extension. That is one of the importance of file extensions. A C code is made up of set of action known as statement that tells the computer what to do. Each time you are programming, you are writing, statement, and each statement is an action that really tells the computer what to do, right? Except for statement that begins with a hash symbol. Okay, any statement that begins with a hash symbol is meant for the compiler. These are known as preprocessor directive. A preprocessor directive is an action which is meant for a compiler. That means what? Before compiling your source code, the compiler is going to scan through your whole source code. It's going to execute each preprocessor statement or directive in your code before compiling your code. Like for example, we have the hash includes here. The hash include statement simply tells the compiler that I want you to copy all the content found inside the standard input output header file and paste it inside my source code. If we want to see what this statement executes to, we can simply right click under our Hello World program and go to properties, and then we go under C and C++ and we go under preprocessor. We can preprocess to a file and we take yes, right, and we take our apply. We compile our code, open our file explorer, go under 64 bits debug, and we see hello world.i. Open this file using our text editor, Visual Studio Code. You can see our program right down here, and everything up here is the standard input output file which was copied by our compiler into our source code. That is what a preprocessor directive is. We also have define, which we are going to see later. We have to set it back to no because a preprocess to a file does not produce an object file, okay? And without an object file, we cannot have an executable. And we apply back our setting. Okay. Alright, compiling simply means the compiler will take your source code and produce an object file for your source code, okay? Meanwhile, we have another tool called a linker. A linker is going to take your object file and different object file and combine all your object file into an executable. All right, so that means if you hit the compile button here, all the compilation is going to take place. Our compilation is successful. We right click under and we go to our file explorer, and here we go under 64 bits debug. We are going to see our hello world.obj. I'm getting ahead of myself. Let's continue. After our include statement, we have int min. This is a function. Now, what is a function? A function is just a named set of statement telling the computer what to do. It is a subroutine that is, instead of writing the same code several times in your program, you could write it only once and call it each time you need it. But in this case, we have a function named the main function. This is a special function because it is known as the entry point to your program. One thing new beginners have to know is that the entry point to your program don't necessarily have to be called the main. You can call it anything. It can be like, for example, main2 or main3. One thing you have to do is you have to tell the compiler that this is the entry point of your program, okay? Because if you don't tell the compiler this is the entry point of your program, for example, if I compile this code here, it's going to compile successfully. But if I build, that is, building simply means I'm compiling and linking, it's going to fail because the linker don't know what the entry point of your program is, and as a result it's going to give you a linking error. You can right click under your project and you come properties, Since the main entry point is a linker error, so you go under your linker, you go under advanced. Under here you can specify what your entry point, what the entry point of your program is. Okay, now nothing is being specified here. That means the main function is going to be the entry point of your program. I hope that makes sense. Okay, the name of this function is called main, and you have braces here. The braces here are the input parameters of the function. This is where you pass in parameters inside your function, and the int here is like the return value of your function. The main function is a special function because if you don't return something and you compile your program, you compile successfully, because without you specifying the return statement, even if you mention here that the return value is going to be int, and without you specifying the return value, the compiler will automatically add a return value for you. So it is a special case for the main function. The rationale is that any command under the Unix system terminates with an integer number ranging from 0 to 255 as an exit status, notifying the Unix shell if it had ended successfully or not. In our case, we use return 0. Return 0 means our program exit successfully, but each operating system has a specific number to determine if a function returned successfully or not. Okay, so for you to write a cross-platform program, usually what we do is we use the exit success macro that notify the Unix shell that our program exit successfully. Now for us to use this, I think we need to include with the exit success macro. You don't really have to bother which operating system you are working on, because each operating system have a different number that describe your exit status. Under Linux or the Unix environment, we both know that 0 means success and 1 means failure, but it is not like a general rule for all operating system. Each operating system can have different value for success or failure. But if you want to see the exit status of your program, type our echo the $sign and a question mark, and it shows false because I change it. I have to compile again my program, then I run it again, run the echo, right? So it shows true. Okay, that means our program exits successfully. Let us return 1 in our program and see. Compile again our program. Let's run our program and let's see the exit status of our program. You see it is false. It means 1 here represents false. That is a function. In the main function, we also have another function called a printf. Now a printf is also a function, right? And for us to use this function, we need to include its function signature, which is found inside the standard input output header. We are going to talk more about this later in the course. So just know that for you to use a function, you have to include the function signature. If I comment this line here and I compile our program, it's going to compile successfully, but if I run this program, it's not going to run because the linker will not know the direct function to link to. Okay, I don't know if that makes sense, but later in the course we are going to understand it. So the linker will not know the right function to link to because we have commented the function signature which is found inside this file. So if I run this program, we are going to have linking error. No, the linker says cannot resolve external symbol printf reference in main. The linker don't know which function it can link to. Okay, on comments back our line, and again you have to know each statement usually ends with a semicolon that tells the compiler that the statement is ended. That simply means that something like this is going to work, but it will be difficult for programmers to read your code. It is not advisable to put all statement on one line. How do you write a comment in your program? So to write a comment, you have 2 ways. You have like the double line for one line comment, for example. This is for single line comments, and for multiple line you use this forward star. For me to wrap up this video, you have noticed 2 kind of error that we have encountered: a compiler error and a linking error. Apart from linking error and compiler error, we have some behaviors that are not ruled by the C standard but are handled by the compiler. These are called implementation by the C standard. Okay, for example, undefined behavior must be avoided while unspecified and implementation defined behavior must be used the right way in order to have expected results. What is an undefined behavior? When there is an error in your code, the compiler is free to generate an error or to ignore them. The compiler can provide like specific results. For example, a buffer overflow is an undefined behavior. And you might be asking me what a buffer overflow is. Buffer overflow, we are going to talk more about buffer overflow in this course because I'm going to really teach you how to write pointers, how to use pointers in a safe way. In essence, a buffer overflow just simply means you are using a memory more than what the memory can hold. You are overflowing the memory. What is an unspecified behavior? The C standard gives choices to the compiler to handle some behavior. This choice may be described by the documentation of the compiler. For example, when a function is called, the evaluation order of the argument is an unspecified behavior. Each compiler have a different way in which it's going to evaluate the order of an argument. Usually it is always advisable to read the documentation of your compiler. We have a whole module for functions. When we're talking about function, we are going to see how different compilers will evaluate function argument in different ways. And finally, we have implementation defined behavior. Some unspecified behavior implementation by the compiler are required to be documented. They are called implementation defined behavior, the number of bits composing a byte. These have to be documented. So these are known as implementation defined behavior. We have seen undefined behaviors, for example, which is a buffer overflow is an undefined behavior. We have seen unspecified behavior, and implementation defined behavior means that the compiler needs to provide documentation of an unspecified behavior. Okay, so we are going to wrap up this video by talking about compliance. What do I mean by compliance? A C program is said to be strictly confirmed if it uses only the feature and libraries described by the C standard and does not depend on undefined, unspecified, or implementation defined behavior. Such a program is portable. Okay, that means what? Such a program can run on all platforms. But for instance, there are some programs that when you write, even if C is a cross-platform language, but there are some programs that cannot run on every platform because of certain behaviors that compilers, vendors are given free chances to implement under their platform. Okay, so as a result, such a program will not portable. That means it will not run under all platforms. But if you write your C program using only the C standard, right, that means your program should be able to run on any platform. The C standard consider two kinds of environment. We have a translation environment. A translation environment is a system allowing compiling C program for an execution environment. I hope that makes sense. Meanwhile, an execution environment is an environment or is a system that runs program compiled from a translation environment. You have to notice that an environment can be both at the same time. We have two kinds of executing environment. We have hosted executing environment. A hosted executing environment is an operating system that have several facilities such as files that can be used by the program, right? Compilers use in this kind of translating environment to generate binary program for a hosted environment is called hosted implementation by the C standard. We also have another execution environment which is known as the freestanding executing environment. Under the freestanding executing environment, we don't have like a whole operating system. We don't have like a file system here, right? Here we have a subset of specialized tools or libraries. So for example, a firmware that manages an embedded system is dedicated to a specialized task, and the compiler used here are known as freestanding implementation by the C standard. It uses only limited set of libraries corresponding to the header file. Like for example, some of the header files we can see here should be like can have something like float.h, limit.h. So under this freestanding environment, you just have libraries simply because you are working standard argument.h, simply because you are working in an environment that maybe need limited resources, right? Maybe in an environment which is not powerful, that or in an environment that want to squeeze all performance and the environment has limited resources. So as a result, you don't need all like the function of an operating system, of a file system. So as a result, you are going to use just the limited libraries under such kind of an environment. Okay, so that wraps up our overview of a C program. I hope this has been informative to you, and I'll see you in the next one.